Let's take a look at multiplying and dividing rational expressions. We're going to multiply and divide rational expressions pretty much exactly like we would do for fractions. Here the only difference is instead of numbers for fractions, we're going to have polynomials in the rational expressions. In the first example, we're multiplying 8x squared minus 8x divided by x squared plus x minus 56 times 3x squared minus 22x plus 7 divided by x minus x squared. In order to multiply and divide rational expressions, we really want to factor first, or factor after making it into a multiplication problem. We'll see that in the next example. And then canceling common factors across the division bars. So in the first one, 8x squared plus 8x, they have 8x in common. We can factor out an 8x. 8x times x will give me 8x squared, and 8x times negative 1 would give me negative 8x. On the bottom, we need to figure out how to factor this x squared plus x minus 56. Similarly, on the top here on the second one, we'll do these to the side, the 3x squared minus 22x plus 7. And then the denominator on the second one, x minus x squared, we can factor out an x, 1 minus x here in the denominator for that one. Now for these quadratic polynomials on the bottom of the first rational expression and the top on the second, let's do these off to the side. X squared plus x minus 56. We can try to figure out what multiplies to be negative 56 and adds to be 1. And for 56, 56 is 7 times 8. So we could multiply 8 times negative 7 to get negative 56. 8 minus 7 gives us 1. So we need to split that x in the middle. We need to split this x in the middle into 8x and 7x, and then we'll bring down the x squared and the minus 56 and factor by grouping. Or if you're using the box method or the area method, those are perfectly fine too to factor. And we should end up with x plus 8 and x minus 7, so we'll put those up here, x plus 8, x minus 7, and we can repeat that on this second rational expression, the numerator, 3x squared minus 22x plus 7. We're going to multiply 3 times 7. We need two numbers that multiply to be 21 and add to be negative 22. And if we think about that one, negative 1 times negative 21 will give us positive 21, and negative 1 plus negative 21 will give us negative 22. And so dividing the negative 22x by negative x and negative 21x, bringing down the first and the last terms, we can factor by grouping just like before, or the area method, whatever you're comfortable with. X in common in the first group, and 7 in common in the second group. And there we have, and then we have 3x minus 1 and x minus 7. So we can put that up top, 3x minus 1, x minus 7. And just cleaning up my scratch work a little bit, I'm going to move those factored quadratics over to the side so I can focus on my rational expressions. Now we want to cancel across the division bar any factors that are the same. So 1 on the top cancels with 1 on the bottom, and it does not matter if it's in the same fraction or in the other fraction, as long as they are completely and utterly identical. So example, x minus 7 here cancels with x minus 7. And there's another one that's fairly visible. X and x will cancel. And then let's write this over again, clean it up a little bit. 8 times x minus 1 over x plus 8, 3x minus 1 over 1 minus x. The 8's do not cancel in that first fraction because I have x plus 8. I don't get to cancel anything with a plus or a minus without canceling the whole thing. We have to cancel factors, not terms. We are not allowed to cancel anything up here in our original problem until we have it completely factored, and then we can cancel. Division and multiplication are complementary operations, but division and subtraction or division and addition are not. So we have to make sure we get them into factored form. Now that they're in factored form and we've canceled some common factors, we just need to check to see if there are any others. Well, it turns out there's one, but it's not that easy to see right off. Notice x minus 1 here and 1 minus x here. If I rearrange x minus 1, I can rearrange x minus 1 so that it becomes negative 1 plus x. And then I can factor out a negative 1, and notice the only difference between x minus 1 and 1 minus x is this extra factor of a negative 1. X minus 1 and 1 minus x are called opposites. Just like negative 5 and 5 are opposites, and if we had them in a fraction, we can cancel them, and we end up with a negative 1. We can do the same thing here with these opposites. If we cancel them, one of them leaves behind a negative 1. Just one of them leaves behind a negative 1. Then we can multiply straight across negative 1 times 8, negative 8 times 3x minus 1, and then in the denominator x plus 8. I will not require you, at least in our notes or on a quiz or a test, to multiply that out. You can leave it in factored form. And that's as simple as we can get for multiplying the two polynomials in number 5. Let's take a look at a division problem now. And in this case, when we're dividing, we want to turn the division into a multiplication problem. So the first step, if we have a polynomial and not a rational expression that we're dividing by, so we're dividing by 4 minus x squared, let's write that over 1 to create a rational expression that we can then work with. Recall, first off, if I had 2/3 divided by 4, this would be the same as 2/3 times 1/4. So we are creating a fraction with the 4 over 1, and then changing the division to a multiplication of the reciprocal. So dividing by a number is the same as multiplying by its reciprocal. Reciprocal is when we turn the fraction, the numerator becomes the denominator and the denominator becomes the numerator. Or, as some of my previous algebra students have indicated, copy, dot, flip. We copied the first one over, 2x squared minus 3x minus 2 divided by 2x plus 1. Change the division to a multiplication, dot. And then we flip the second one. Instead of being 4 minus x squared, now it's 1 over 4 minus x squared. And we've turned our division problem into a multiplication problem that we can now work with. So now that we have the division problem turned into a multiplication problem, we can do what we did in the previous question, which was factoring out these polynomials and canceling like factors. I notice in my second fraction, 4 minus x squared, that's a difference of squares. So that always factors as sum and difference of the same terms. So 4 is 2 squared, and I end up with factors of 2 minus x and 2 plus x. The numerator on the first rational expression, 2x squared minus 3x minus 2, we're going to need to break that trinomial down a little bit further. A is 2, B is negative 3, C is negative 2. So A times C, 2 times negative 2 will give us negative 4. B is negative 3, and I need two numbers that multiply to be negative 4 and add to be negative 3. So I can try 1 and negative 4. 1 times negative 4 is negative 4. 1 plus negative 4 would give us negative 3. And then I can factor 2x squared minus 3x minus 2, break that 3x into minus 4x plus 1x, and then bring down the 2x squared and then minus 2. Factor by grouping, group the first two, group the last two. 2x squared and 4x have a 2x in common, and I'm left with x minus 2. Plus sign comes down. 1x minus 2 has a 1 in common, x minus 2. Common factor of x minus 2 comes out, and then 2x plus 1 left over. I can put that up in my numerator in the first rational expression, x minus 2, 2x plus 1. Now I can consider canceling like factors. I have one pretty obvious one, 2x plus 1 can be canceled. The other one isn't as obvious, x minus 2 and 2 minus x. These are opposites again, just like the previous x minus 1 and 1 minus x. Simplifying this rational expression by multiplying across on the top, x minus 2, and across on the bottom, 2 minus x, 2 plus x. I can cancel the x minus 2 and the 2 minus x, but I've got to leave behind a negative 1. And in doing that, I get negative 1 over 2 plus x, or negative 1 over x plus 2. The order of the sum in the denominator does not matter. So negative 1 over x plus 2 is also perfectly acceptable as an answer for this problem.